Hey, I'm Robert. I lead the DIY business for Intel. Welcome to The Blueprint. We're here to talk about Intel Application Optimization, which we're just going to call APO. You can call it APO too. And what I've drawn here is, a game, sort of, and a 24-core CPU, which in this case is the Intel Core Ultra 9 285K. Here's how APO works. Let's start with the basics. If you're a game developer, you have a machine at your desk with a certain number of cores that you're designing that game on. And your QA testers have a machine with a certain number of cores that they're testing the game on, and you're probably targeting a game console, which has a certain number of cores. And that's why most games tend to target 6, 8, 12 threads, because they kind of fit comfortably on the CPUs that game developers tend to have and consoles tend to have too. So, when that game comes to PC, a few things can happen. You can just have it spawn 8 threads. We're not going to go to 8 because I'm not going to sit here and count to 8 and draw 8 lines, but you generate a number of threads from that game equal to the core count that you're targeting. Every thread has a nice home on it. But what if you run into a CPU like our 285K with 24 cores, or other CPUs in the market with like 32 threads? Well, the game might do something very different. It might just keep spawning more and more threads until it gets up to 24, and that's a problem. That's called overthreading. When the game spawns so many threads, the act of managing the traffic to keep them all talking to one another, that actually ends up being a performance loss. The performance goes backwards for spawning that many threads. And you don't want that, right? You don't want a huge number of threads spawning and your performance going backwards. So this is where Intel APO can help. And we're also going to add one other thing here. We're going to add a GPU, because that also has its own threads going to the processor, right? There's a GPU driver. The GPU has to talk to the processor as well. So you've got all these threads in flight. And what APO can do is cut it down. APO can cut down the number of threads that are in flight, sometimes by tricking the game and saying, hey, I'm only an 8-core CPU, or I'm only a 12-core CPU, or don't use this piece of my processor because it's not helping you. Right? APO sits in the background and can nudge these threads around to make the application and the GPU utilization of that application more efficient for the processor you are running. And the reason why there's a list of games is because not every game needs this kind of help, and not every game has the same benefit. Some games spawn more threads, some spawn less, some don't make the same errors that other games do, and some use the GPU differently, right? So all of those characteristics are really important for how APO functions, which is why there's more or less benefit depending on the game that you run and the hardware that you have. We have to optimize all of this as it exists in your system on the game that you are running. And that is how APO ultimately functions, by trimming down how the game and the GPU is using your processor, making things faster on the other side by preventing that overthreading problem, amongst others. Hey, I'm Robert, host of Intel Blueprint, where we make the hard stuff easy by drawing about it. You'll learn how CPUs fit together, how these components talk to one another. Hit that like and subscribe button. I'll see you in the next episode.